This video focuses on just a couple examples of those transformations that were just explained in the last video. They get to be pretty overwhelming, so I just want to put it a little bit in a better scenario for you. So this first example, we give you the parent function, f of x equals the absolute value of x. So think of that as the shape of a V. And then we give you a new function, g of x equals the absolute value of x minus 2 plus 5. We want to find out what is the transformation, what is the critical point, and how do we graph these two functions on the same coordinate plane. So let's just take the parent function first in the blue and evaluate it for just a few numbers. Let's say -2, -1, 0, 1, 2. We're evaluating it for f of x, so we're substituting it in for x. So when we take the absolute value of -2, we get 2. Absolute value of -1, we get 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. This ordered pair is what we call our critical point, 0, 0. So let's just graph that parent function for the absolute value of x. So we have 0, 0, 1, 1, 2, 2. -1, 1, -2, 2. There is my parent function in the blue. We say f of x equals the absolute value of x. Now we want to have a new function with some transformations in it. What are those transformations? So there's one transformation that's inside the function. That's a -2. So we need to shift that to the right 2. It's a horizontal shift, right 2. This piece is outside the function. It's a +5. So that's a vertical shift up 5. So we have two movements, right 2 and up 5. So what you do is you can take your critical point, 0, 0, and shift it right 2 and up 5. What that new critical point will be is 2, 5. Now it's just going to be 1 right, 1 up, 2 right, 2 up, and then the same thing here with that symmetry. Now we have our new function, which we call g of x, with the transformation and the critical point. If we ask you for the domain of this function, or the range of this function, could you identify that new red function? The domain for x, for g of x function, the domain would be all real numbers. The range starts when the y is at 5, so y is greater than or equal to 5. And this is what for the g of x function. Our second example, we give you a parent function, and now it's a radical. It's a square root. Let's evaluate a few ordered pairs here. For f of x in the blue, -2, -1, 0, let's do 4 and 9. All right, I'm evaluating it for f of x, and we're square rooting it. Remember, when you square root a negative number, these two do not exist. They don't work. You can't have a negative square root. That brings into imaginary numbers. Now let's go into that first one, the square root of 0. The square root of 0 is 0. So that's going to be my first order pair, which is my critical point, 0, 0. Actually, that's going to be for my new transformation. So we'll call this our critical point. I'll just change that to green. And that's my critical point, 0, 0. Now let's take the square root of 4. The square root of 4 is 2. The square root of 9 is 3. So quick sketch there. There's 1, 1. Here's our critical point, 0, 0. Now it asks us for a new function in the red with a negative in front of the function. When you have a negative in front of the function, it reflects it about the x-axis. So if I imagine my x-axis being right here and I create a folded piece of paper, what would my graph look like? Well, this point would stay, so that's still my critical point. And now I have over 1, down 1, over 2, down 4, over 3, down 9. That's not pretty. Our critical point is 0, 0. If we ask for the domain and range of this red function, which we call g of x, the domain will be from 0 to positive infinity. Our range will be starting at 0 and going to negative infinity. So we should say negative infinity to 0, or y is less than or equal to 0.